பண்ணிட்டேன். ஹலோ மேடம் கேக்குதுங்களா? ஹலோ ஹலோ மேடம். ஆ சௌமியா மேம் வரல, இன்னும் வேற பார்ட்டிசிபென்ட்ஸ் யாருமே வரலையே. ஓகே ஓகே. இந்த பேசுங்க. எந்த ஃபோனில் ஸ்டோர் பண்ணிருக்கீங்க நம்பரு? சரி சரிங்க. ஹலோ மேம், வணக்கம் மேம். இப்போ உங்களோட ஈவெண்ட் இருக்கு இல்லையா, கனெக்ட் பண்ணிடுறீங்களா மேடம்? மேடம் 1 ஹவர் மேடம், 5 to 6 பார்ட்டிசிபென்ட்ஸ் வந்துட்டு இருக்காங்க. இல்லை, இன்னைக்கு ஆக்சுவலாக பவர் இல்லைங்க மேம் எங்கள் ஆஃபீஸில், அதனால யாருமே காலைல இருந்து ஆஃபீஸ் வரல. இப்போ தான் நான் வந்து கனெக்ட் பண்ணிட்டு இருக்கேன். பீப்புள்ஸ் ஆட் ஆகிட்டு இருக்காங்க. நீங்கள் கொஞ்சம் உள்ள வந்துடுங்க. ஓகே. Soumya, good evening.
Good evening, sir.
Shall we start the program?
Yeah, sure, sir.
Saranya, ma'am?
Sir, am I audible to you?
Yes, ma'am, audible, ma'am. Saranya, ma'am, are you there?
Yes, sir.
Saranya, ma'am?
Yes, sir. Yes, audible, sir.
Yes, ma'am, you can. I would like to call Saranya, ma'am, to give one welcome address for this event.
Good evening, everyone. It's my privilege to extend a warm welcome to all the participants, esteemed faculty members, and our distinguished resource person, Dr.Sowmiya.B, Assistant Professor of at S.I.V.E.T College, Chennai, to his first international faculty development program on the future of innovation, exploring machine learning. This program marks a significant step toward understanding the dynamic field of machine learning and its potential to revolution innovations. We are fortunate to have Dr. Sowmiya with us, whose expertise will provide valuable insights into his transformative domain. Welcome, ma'am. Welcome to the session, ma'am.
Thank you, Saranya, ma'am. I hand over the session to Dr. Soumya, ma'am, Assistant Professor, Department of Computer Science, S.I.V.E.T College, Chennai. Thank you. You can start the program, ma'am.
Thank you, sir. Thank you, ma'am. Okay, am I audible now?
Yes, ma'am, audible,
Yes,
ma'am.
ma'am. Yes, ma'am. Audible, ma'am.
Sure, sir. I'll continue. Hi, good evening, all, to the faculty development program entitled The Future of Innovation Exploring Machine Language. The topic I'm going to discuss today is machine learning and introspection. I'm Dr. B. Sowmiya, Assistant Professor, Department of Computer Science, S.I.V.T. College, Chennai 73. So let's look into the agenda portion. These are the things that we are going to cover today. The introduction, what is AI and why machine learning, understanding the basics, the core algorithms, followed by the advanced topics in machine learning, current research frontiers, practical applications, future directions, and the session ends with the interactive Q&A sessions. So let's quickly get into the topics. A quick quiz. Can you answer the question that is displayed there? What ML technique Netflix uses to suggest the shows that you might like? Anyone? What ML technique Netflix uses for its suggestions and recommendations?
No.
Okay. It's nothing but the recommendation algorithms. There are many types of recommendation algorithms available. So Netflix uses the proper recommendation algorithms for customer segmentation as well as suggestions. Right. And next comes AI, which is a super term that we all know. AI is nothing but the ability of the computer or the machine to mimic the human capabilities or human intelligence. It uses data, algorithms, and computing power to perform tasks like learning, problem solving, reasoning, and decision making. In simpler terms, AI is like electricity powering ideas, and it is used for changing the world that we everyone uses. So let's look at the very shortest history of AI. The AI is not the term which is coined in the 2Ks. It is coined in 1950s itself when Alan Turing introduced the Turing test, and it was officially named in the year 1956 at Dartmouth conference. And in 60s to 70s, the ELIZA, the chatbot, was created, and AI faced several setbacks due to the limited technology. In 1980s, the decision making, that is the expert systems, became very popular. And in 1990s, Gary Kasparov, he was beaten by IBM's Deep Blue. It was one of the major innovation. And in 2010 era, AI powers smartphones, and it has several breakthroughs in self-driving cars like Tesla. And in the past, and we have seen the innovations from 1950 to 2010, and in the nearing future, through ML algorithms, deep learning, and GAN networks, and through many and many techniques, the AI will power the entire world. The main thing that we focus is the decision making. Vast difference between the human and the machine, how they both take decisions. Human take decisions with intuition, emotion, with a lot of experience and cognitive reasoning. But ML doesn't truly think like a human. It gets trained on a vast amount of data. Like a child used to learn from a lot of data, the ML gets trained using a vast amount of data. And based on the mathematical algorithms, models, and patterns, it take decisions. So that's how a machine learns, and it take the decision just like a human. And now, what is machine learning? We all know it is a subset of artificial intelligence. So it is clear that AI is the broader umbrella term, and ML comes under that. It involves system that learns from the data, it recognizes patterns and improve over time. That is, it is not stagnant. Day by day, improvements, there are a lot of improvements. It gets trained from several vast amounts of data, and they often become better at decision makings, and usually it mimics the decision making aspect of human and the problem solving. So one more quiz. What kind of ML algorithm allows a car to navigate on the roads safely? So, what kind of ML algorithms allows a car to navigate on the roads safely? So, any guesses?
Ma'am,
Maybe
can
it is
you
right
give
or
one
wrong.
or two algorithm names to identify?
Yeah, through algorithms. What type of algorithms?
No, you are said the MUD allows a car to
Yeah,
navigate roads safely, but I don't
yeah,
know which
sure.
type of algorithms
Yeah,
are.
we don't know the exact name, but we may know something like computer vision, sensor fusion algorithms with a combination of data analytics, sensor fusion, and computer vision. ML algorithms allows the car to navigate on the road safely. Thanks
Yes,
for your guess.
yes, ma'am. Yes, ma'am.
So we have seen what is machine learning, and there are several types of machine learning, and the most important types are projected here. Number one is supervised learning. Number two is unsupervised learning. Number three is reinforcement learning. So in this slide, in terms of supervised learning, the input is data and label. Both data and label are provided to the system as the input, and the output will be mapping to a particular class or a particular group. And in case of unsupervised learning, there is data but no label is given. This is the main term that we need to underline. There is no label, and the output will be either class or groups. So, in case of clustering algorithms, the classes will be the output. In case of non-clustering algorithms, the groups will be the output. There are some minute variations among the classes and groups. So only when we are making some hands-on, we will understand what is class and what is a group. And in third case, reinforcement learning, the ML algorithm, it will actually learn everything like a child. Data and the label is not given. The output will be probably mapping as well as classes. So, supervised learning has label. In all the three algorithms, we provide the sufficient enough data. So, and in the first category, supervised learning, there is only label, and in the second and third cases, there is no label. Only the data will be given. It will be probably in self-learning mode. And by self-learning mode, it will understand the patterns, analyze, and in case of reinforcement learning, either positive or negative rewards will be given. Positive rewards means plus 5. For example, plus 5 points will be given. And if it is the wrong choice, then the negative marks, minus 5 will be given. So like that, the reinforcement learning will continue. One more quiz. What type of machine learning is primarily used to enable a car to navigate roads safely in case of autonomous car driving systems? Supervised, reinforcement, or unsupervised?
Supervised.
Okay. Any other guesses?
Participant, may I have you?
And reinforcement learning as well.
Yeah, among the three choices, reinforcement suits well. Because autonomous driving cars means, we all know Tesla self-driving cars, they learn everything. Start from the signal, start from the each and every driver operations, it will learn. So, not in the very first attempt, the car will move in a smooth mode. Through reinforcement learning with the positive and negative rewards, it gets trained. So, definitely there is no label. We can't provide label for all the cases. So the B suits will. Reinforcement learning will be used in autonomous car driving systems. Okay. And ML terms. Some of the ML terms we need to discuss. There are hundreds of terms, and here I have taken very few terms. Number one, dimensionality reduction. We all know ML algorithms need a lot of data to getting trained. So, say for example, I'm providing an Excel sheet with 100 columns, 100 cells, and 100 columns, and almost 1 lakh of data. So, the system does not need that much of data. So it needs some type of filtering. That type of filtering is known as dimensionality reduction. Only the intended variables are given. The variables that are needed for the system that will influence the model will be given, will be input into the system, input into the model, and the other things will be rejected. So, for example, the whole entire sheet is not given. 20% of the data is alone needed means I will segregate and I will filter and I will pass that 20% of data to the ML algorithm. So that is dimensionality reduction. It is used for speeding up the process and for the exact calculation. And other terms are clustering and classification. So clustering means grouping the similar terms. The recommendation algorithms usually use the clustering algorithms. Clustering means similar things are grouped together. Like when I purchase something in an e-commerce site means similarity. My choices will be taken together according to the user. And the classification is usually a labeled one, categorized one. For example, I'm classifying from my mail either as a spam or not spam messages. So classification has predefined labels. This comes under supervised that we have seen. So in the last slide, data as well as the label will be given. So the fourth term is regression. Regression is nothing but predicting the continuous values. Continuous values means house price estimation. For example, house price if I want to calculate the house price for the particular region, particular area, it may cost around, for example, the particular place X cost around 10,000 to 20,000 means the minimum value is 10,000 and the maximum value is 20,000. So there is some range, there is some continuous set of values. So problems like house price prediction, for the problems like house price prediction, I use the regression algorithms. And the final goal is prediction. Prediction is nothing but my model will choose or classify the results based on the particular values. That is known as prediction. So either I can classify as a cluster or I can go for the continuous values in case of regression. It depends upon the problem. I should choose one particular algorithm, one particular classification criteria. So what are the steps for solving an ML algorithm? So these are the simplified steps I have given. So step 1, I have to define what is the problem. I should understand what I am trying to solve. And the second step is I need to gather the relevant data collection. Step 3, I have to prep up the data. I have to I have to think of the data, which data I have to use, which range I should fall in, and everything. So I have to prepare the data. I should make some filtering, so several mechanisms. In terms of if my data is a CSV file means I will eliminate several columns. If my data is an image or a video means I have to make some filtering operations. I need to crop some particular portion. For example, in case of disease detection, if I pass an image means the entire image is not needed. In case of disease means only the diseased portion area of the image is picked up. So I need to transform my data. The actual image is X means it should be converted into Y. That Y is only the relevant features. The relevant feature will be passed into the particular model. And then I have to choose the right algorithm. There are several algorithms, say 20 or 30 algorithms. I need to select the right algorithm for the particular problem. And I need to train the model. Train the model means all the data are passed into the model and I am trying to test. I'm training the model for right predictions. And then I evaluate the model. That is, I test the model whether it works rightly and predicts the right classification. And then I need to fine-tune the hyperparameters. Fine-tuning means the model may work well, but in the future it may not work well. So I need to adjust with the parameters, just like we are using a radio system. For example, we are using a radio system means we will adjust the buttons and everything there, no? So like that for better outputs. Like that, I'm fine tuning the hyperparameters. Just I'm adjusting the settings. It is usually done by the ML developer. And finally, I'm deploying the model. And after deployment, I just monitor and maintain the ML. So these are the steps involved in the machine learning problem. So this is one particular sheet that I downloaded. It is called as ML cheat sheet. And after the presentation, if you look at this, you may get some idea. So now we leave this sheet and move on to the next slide. Right now we are taking 8 ML algorithms in Python. Linear regression, logistic regression, KNN, decision tree, naive Bayes, SPM, random forest, and K-means algorithm. So now I just stop the machine learning algorithms. Linear regression, this is the first algorithm that we are going to see. Linear regression is nothing but X is given, I will predict Y. So X is the independent variable and I will find out what is Y. That is the dependent variable. So this is simply linear regression. Given one variable, another value for the variable is predicted. So X as the input means I will produce the Y as the output. Example for a linear regression, Walmart uses linear regression to predict the future sales based on the past sales trends. For example, with the history, I may analyze the trends. How my business is going to be in the particular season or the particular festival or for the particular month. Some educational platforms like Coursera and Khan Academy uses LR model, linear regression model, for providing the personalized support to the students in order to improve the student retention and the success rate. Next comes logistic regression. Logistic regression is another kind of algorithm similar to linear regression, but the classification here is binary, that is either true or false, yes or no, spam or not spam. So like that, it is a binary classification algorithm and it uses sigmoid function to return the probability of the label. Probability usually takes two values, yes or no. The real-time example, Gmail, it uses logistic regression for email classification. And one more, Mayo Clinic uses logistic regression algorithms with other predictive analysis techniques for assessing the patient's risk level for various diseases like cancer and breast disease. Next algorithm, before that quiz. What type of machine learning is commonly used to diagnose the diseases early from medical images, such as detecting tumors in X-rays or MRIs? Supervised, unsupervised, reinforcement, and the fourth case we have not yet seen. We will discuss later, transfer learning. For disease detection, which ML algorithm is used? Can I get the answers from you?
Transferred learning, ma'am.
No.
Okay, ma'am.
Transfer learning is not yet discussed and it is not the right answer here.
Ma'am, that is supervised.
Yes, correct, sir. In case of disease diagnosis mechanisms, data is given, and we clearly give to the machine. That is, we clearly give to the model the data as well as the label. For example, I'm training my model with the hundreds of data. In the hundreds of data, I will divide. These are the disease patterns and these are the healthy patterns. So clearly I'm giving the data and the label. Label means I'm dividing into folders, several folders. In folder 1, I'm having the healthy patterns and in folder 2, I'm having the diseased patterns. So I'm classifying this is the data or that this is the data for this case or that case. So clearly for disease detection mechanism, supervised learning is more suitable, right?
Yes, ma'am. Thank you.
And next algorithm is k nearest neighbor. And we have seen classification, clustering, regression. So KNN is used for both classification and regression task. So already we have seen regression means continuous data like house price prediction. Classification means labeling, spam or not spam, like that. So KNN is a mix-up of both classification and regression task. So it predicts based on the closest points in the feature space. And for the given input, find the k nearest data points into the feature space and make predictions based on the labels or values. That is, a graph will be the output and the graph will cluster. Based on the closest points, it will make a cluster. And with that cluster, I will come to a conclusion or a prediction. The real examples. Pinterest uses KNN algorithm for finding the similar images and also recommendation of visually pinned images. Usually pattern recognition and recommendation uses the KNN as the ideal algorithm. And next, decision tree. It is used for both classification as well as regression. Decision tree. In data structures, we are familiar with the term tree, with the root, node as its elements, branch as its elements. So similarly, a tree is drawn. From the given data pattern, a tree is drawn. Tree with root, node and branches. And one more problem here is overfitting. Overfitting is a problem with the decision trees, and in order to solve the overfitting issues, pruning and ensembling can be used for overcoming the overfitting issues. Not only overfitting, major issues are happening with the ML models, and for every issue there is every problem there is a solution. And pruning here controls the complexity of individual trees. That is the tree has unwanted things and unwanted features. So that can be controlled with the pruning technique. Pruning is nothing but one sort of algorithm. And ensembling means I'm combining several trees and it uses something like voting procedure. So it combines several trees to make the model more generalized and it helps to mitigate the tree has unwanted things and unwanted features. So that can be controlled with pruning technique. Pruning is nothing but one sort of algorithm, right? And ensembling means I'm combining several time of day trees and it uses something like voting procedure. So it combines several trees mechanism with decision trees. And also it finds where the more drivers are needed and allocates a driver accordingly. So they can reduce the waiting time and overall customer experience is enhanced. So next comes naive-Bayes. It is based on the Bayes theorem, which is nothing but a probabilistic classifier, and it is used for classification task. Google News uses the naive-Bayes classification algorithm, which recognizes whether the news is political or world news or anything. And one more algorithm, S.I.V.E.T, and it is used by most of the researchers, and it is a powerful supervised learning algorithm used for classification as well as regression. And it works by finding the hyperplane that separates the data point from different classes, maximizing the margin between the classes. All the points are plotted on the something like a graph, and a line is drawn that is known as the hyperplane that acts as a margin that separates into data points into classes. So, and if there is a one particular line, two different type of clusters or classes means this is class A and this is class B. So with this, it will come to a conclusion. For binary classification problems, for example, spam or not spam, yes or no, for such outputs, two class classifications or binary classifications, SVM is more suited. And it is also works best for high dimensional data. The kernel in SVM, it helps to separate the complex data. The kernel plays a major role in separating the complex data into a higher dimensional space. And it makes possible to classify the data with non-linear patterns. There are two types of patterns: linear and non-linear patterns. For non-linear patterns, SPM's kernel plays a major role. The real-world examples are facial recognition, voice recognition, and image sorting. Facial recognition, Facebook and Google Photos uses a SVM algorithm in order to recognize the faces in the photos, and that helps to organize the people that every day we use. And voice recognition, Apple's Siri and Google Assistant uses SVM to understand and respond to the spoken commands. And image sorting, SVM uses the Google Photos and organize pictures by recognizing and grouping similar images. So SVM is used for similar classification as well as for continuous data, continuous pattern finding, both classification and clustering. Classification and regression task. And one more algorithm, random forest. We have seen what is decision tree. It's just like a tree with n number of elements like root, node, branches, etc. So random forest is ensemble of multiple decision trees. It is a combination of multiple trees. So instead of relying on one particular tree, random forest uses multiple trees and makes voting decision from each of the tree, and it combines several voting decisions and predicts the final output. So whenever there is a tree, there comes a overfitting issue, so that can be prevented with several algorithms like pruning, etc. That issues might be prevented. And the outliers means missing data. So whenever we collect a Google form, we may miss some data or we get some irrelevant data. So that is called as outliers. So in case of outliers, data with outliers, random forest works well with the outliers type of data set, and it produces high accuracy on such cases. Real world example, the RF classifier is used in Amazon for product recommendations, customer segmentation, etc. With the use of purchase history, patterns, etc., it makes some recommendations. And K-means algorithm, it is used for clustering problems. Clustering, not for classification, it is used for clustering problems. So K-means group together similar data points into clusters by minimizing the distance between the points. It is also one type of, it is clear that K-means is a clustering algorithm. All the data clusters are plotted and the distance between the two data points are calculated, and the similarity is focused here. And based on the similarity, a cluster is formed, and from that cluster, it is considered as cluster A or cluster B. So cluster A means prediction A or cluster B means prediction B. So the data points play a major role here. The practical applications include Walmart, which uses the K-means to segment customers into groups based on the purchasing behavior. Facebook and Instagram uses the K-means with the image compression algorithms. For example, the Google Photos don't use a whole set of images. For example, we are uploading a lot of data, but the actual, for comparison purpose or for some segregation purpose, only certain elements of the image are taken. That is known as image compression. And for image compression, K-means algorithm is employed by Facebook and Instagram. And Amazon uses K-means to identify the frequently purchased items combinations for for product recommendation. So the most important algorithms are discussed: linear regression, logistic regression, KNN, decision tree, naive Bayes, SVM, random forest, and K-means. So not one particular algorithm is suited. We have to trial and test with all the algorithms, or depends upon the problem case. We need to choose the certain algorithms and we need to work out, and from the accuracy we should find which algorithm suits well for which particular problem. So there are so many algorithms. So among the algorithms, which one should we choose? So based on some from these algorithms, how can I choose? Classification, regression, dimensionality reduction, and clustering. So every problem will come under either one category. So either with the category based, I can go and choose one particular algorithm. So if it is a classification problem, means I can use SVM, KNN, or naive Bayes. If it is a regression type of problem, I can use a linear regression, logistic regression, or decision tree. And in case of unsupervised learning, I can use LDA or PCA, linear discriminant analysis, or PCA algorithm. And in case of clustering algorithm, means grouping of the data points, I can use K-means or K-medioids. Application wise, we can select either with category wise or application wise, we can select particular algorithm. If my problem is fraud detection or spam detection or diagnostics, disease diagnosis mechanisms, or image classification, I can go for the classification algorithms. Risk assessment, score prediction, or as we said, house price prediction, I can go for the regression type of algorithms. In case of supervised, unsupervised learning, if I want to recognize some face, recognize some images, or if I want mining type, text mining, or visualizations, I can go for the dimensionality reduction. And target marketing, and if I want to group the customers or I want to make some plan, means I can go for the clustering type of algorithms. And reinforcement, it is completely different. It is suitable for the gaming or the finance sectors or something like robot navigations. So I should clear with the problem and I should clean the data, and after cleaning the data I should pass the particular filtered data to the system model, and I should train the model, and I should find whether the model suits well and produces best results, and if needed I should hyperparameterize the model. That is, I need to fine tune the model and I should check the results again and I can continue with the model. And the one more term, hyperparameter optimization, we already discussed. It is just like buttons and gears of any system, or buttons and gears of a radio system. The settings, how I'm controlling, settings that control how a model learns from the data. So they usually influence how the model trains and make predictions. Just I need to adjust the hyperparameters for better accuracy, better speed, and better performance. Usually they are set by the ML programmers. When I'm training a particular model, means I will set the hyperparameters manually. So I will frame the problem. That is, I will define a problem, obtain the data collection, and get insights from the data. Insights from the data means picking up the relevant features, relevant data. From the data, I am exploring the relevant data. Original data is there, and I am segregating the important things, wanted data, relevant data. That is the data that I'm actually getting supposed to be passed into the machine learning model. And I'm preparing the data for ML algorithms. That particular prepared data is sent to the model, and the model will fine tune will be fine tuned for the results, and I will present the solution. If this step, fine tuning the model, if it is okay and if it is preferable, I can continue with the present solution. Else, I need to continue with the loop. I should fine tune the model again and again. And the final stage is deployment and maintenance. Deployment, monitoring, and maintenance of the ML model. Hyperparameter tuning techniques. That is adjustment. How can I adjust? Through several algorithms: grid search, random search, Bayesian optimization, gradient based optimization, and evolutionary algorithms. I can fine tune the model using the hyperparameters. So grid search is nothing but I will test all the combinations one by one. For example, I can take X, Y, or X, Z, like that. I will take and test the combinations. So random search means I select the combos X, Y, or X, Z, or X, Y, Z, all the three. And Bayesian optimization, it is nothing but from the previous combos, I will select anyone. Smart choice, taking the smart choice, and it will usually save time. Randomized grid search means grid search plus random search, a mix of both. Genetic algorithms, here the best parameters are selected and combined over time. And it usually genetic algorithms, mutation comes under genetic algorithms, and more steps are inside the genetic algorithms. Just like a biological term, it has the inner process. And gradient based optimization, slowly the hyperparameters are adjusted, and over the time it's getting improved. So with any of the search methods or optimization methods, I can fine tune the hyperparameters. And so far we have seen the basics of machine learning, and it's not the end. CNN and deep learning are the next advanced topics in machine learning. CNN is nothing but special type of neural network for a classification task, analysis task, or a detection task. And deep learning, it is a subset of neural network. It is more, as the name suggests, it has deep or more number of layers. And the major difference between machine learning and deep learning is machine learning and deep learning and CNN both are specialized in automatic feature extraction. That is, a manual process are maintained as a black box in CNN and deep learning. Some handcrafted works should be done by the ML developer, and that will be automated by the CNN and deep learning layers. With this diagram, everything can be easily understood. Start from the inner circle, smallest circle, deep learning, which is a subset of neural network. A neural network is a subset of machine learning, and machine learning, which is a subset of the higher umbrella term, artificial intelligence. The entire things will be controlled like robots, and which is ML, which is a part of a artificial intelligence, and neural networks and deep learning are a subset of machine learning. In the current research frontiers, transformers and LLMs, nothing but the chat GPT and the technologies that we use today, and the reinforcement learning and the deep reinforcement learning. Transfer learning means I know in machine learning I need to create everything from the scratch, but in case of transfer learning, there is one pre-trained model. I add something to the model and I can use it. It is known as transfer learning. And meta learning, it helps for better understanding from the already created model. So transfer learning and meta learning, we don't need to create anything from the scratch. And self-supervised learning, it is just like reinforcement learning. It is a mix-up of supervised and unsupervised learning. And generative models and diffusion models, explainable AI and AI ethics. These are the current research topics that I can say. And next, the practical applications. The practical applications includes in all the sectors in healthcare. The disease diagnosis mechanism includes a lot of ML algorithms. For example, doctors nowadays use ML algorithms to predict the chances of risk and drug discovery. In one, in say for example, in 5 minutes or 10 minutes of time, a model can generate n number of solutions and it can create n number of drugs. And for personalized treatments, ML can be used. And in second case, finance, fraud detection, and for trading and all, ML algorithms can be utilized. And in sector 3, e-commerce industry, customer, as we discussed, customer segmentation and the recommendation systems for inventory management, e-commerce. For example, if one particular product is getting sold out more and more, means I can start autonomous vehicles, Tesla, and the route optimization, especially for drivers. For these things, we can use the ML algorithms. And in agricultural sector depends upon the climate and with many factors I can control with not only with the ML, with several um, advancements like IoT. From the remote location I can monitor a particular farm and I can precisely control the water level management and everything, as well as I can detect the disease from the particular plants. So if I input particular leaf, means the system will detect for the patterns and it will check whether the disease is, whether the leaf is healthy or unhealthy. And energy efficiency, um, smart grids, energy efficiency, smart grids, renewable energy forecasting and all. ML is again used. And in educational sectors for student grading mechanisms and personalized trading mechanisms, personalized learning factors, ML algorithms are used. And not only, the list goes on. Entertainment sector and telecommunication, sports and fitness, real estate, and in last, the ML application goes on. So the future direction and challenges: data privacy and security, bias and fairness, explainability and interpretability, scalability and efficiency, generalization across tasks, and real world application. These are the challenges and these should be mitigated. Some suggested solutions for the above mentioned problems. For data privacy and security, we have to protect the sensitive data through several techniques, like the well-known techniques like encryption, or through federated learning. That is, from multiple sources I get the data. And second is bias and fairnesses. Through regular audits, transparency in algorithms, and fairness aware algorithms and bias reduction tools, I can get rid of the bias and fairnesses. And third one is explainability and interpretability. This is one way of avoiding the black boxes. As I already told you, something the ML is not in such a case. The advanced ML algorithms, advancements of algorithms, which include CNN and deep learning, they are usually of black box type. That is, we can't interpret anything there. So by avoiding the black boxes or making the systems simpler and using the explainable AI, I can ensure the explainability and interpretability. And scalability and efficiency. Through transfer learning, efficient algorithms, and edge computing. Edge computing means um, through the nearest devices, I can load my data and I can test. I don't need any cloud services in some cases. So that is a one way to bypass these problems: scalability and efficiency, and generalization across tasks. To mitigate this problem, I can also use the transfer learning, meta learning, or regularization. Regularization means there are more and more neurons in case of deep learning and machine neural networks. Deep learning and neural networks. So I can eliminate some quantity of neurons. So I can cut down some neurons and I can test with the remaining kind of neurons. So that is generalization. That is regularization. So in the real world application, how I can improve means through robustness testing, data augmentation. Data augmentation means given one data, I can make replication of the same. That is data augmentation and using the human capabilities, human decision making skills in case of complex or high risk scenarios. So these are the suggested solutions for the above mentioned problems. So my part is over. Thank you all. And all your queries are welcome.
Thank you, ma'am. Any queries from participants?
Thank you, ma'am.
Thank you, sir. Thank you for giving me this wonderful opportunity to present.
Thank you, ma'am.
Thank you, sir.
Thank you. Participants, we can connect by tomorrow for the next session. Thank you all.